you're wondering who Tom Wurm is, that's me. So I'm your host. Welcome to the London ClickHouse Meetup. I don't work for ClickHouse Inc. I work for Cloudflare. So my job right now is to tell you how amazing Cloudflare is. It's amazing. And if you're interested in what positions Cloudflare has to offer, head on to our careers page. It's got a long list of things that are really fun to do and interesting. And hopefully our presentation from Sean tonight will persuade you of that further. But I do have to do a couple of housekeeping things. So the first one is fire exits. In the event of emergency, there will be an alarm that goes off. And the fire exit is opposite the lift on the way when you came in. The toilets are all the way at the end of this room, all the way to the back. And lastly, the lift keypad is really confusing. So when you leave, don't press 1 or 0. That's unsafe. Press star, because that'll take you all the way to the bottom. If you don't press star, you'll get stuck in the in-between land of God knows what. Alyssa got stuck earlier there.
It was scary.
Yeah. And yeah, that's awesome. So I think that's all I have to say. So I will invite Pascal up to speak some more.
Okay, Tom, and thanks for hosting us, of course. We're very pleased with this. We're very pleased actually with the turnout. So maybe a few more people drop in. Over 100 people registered at least for the event for tonight. So let's see if a few more potential ClickHouse users or those who are interested in ClickHouse will actually join us. So we have actually created a program. This is our, if I'm not mistaken, the first ClickHouse meetup here in London. And probably many more to follow after this one. We see a huge adoption. As you may know, ClickHouse Inc. started officially on the 1st of August last year, so we're close to 1 year old. Today we're 90 people. Also here, have a look at the website on the career page. If you're interested in joining ClickHouse, we're growing quite rapidly at the moment. We expect to be around 150 to 160 people by the end of this year. So, and those are mostly engineering, cloud engineering, software engineering, UI. There are a whole bunch of jobs listed on that page. So feel free to have a look and apply if you're interested. So, as I said, we're growing quite fast. In the last couple of months, we've been super busy actually developing ClickHouse Cloud. Anyone that is interested in ClickHouse Cloud, that's our commercial model going forward. As you know, we're open source under Apache 2.0. There's no change there. We will deliver each month a new release. We increased actually the ClickHouse core team to close to 40 people. So you will see a lot more over the months to come, more features and functionalities being delivered in the product, which is awesome. That's exactly why we built the product and how we deliver it. But if you're interested in running a serverless ClickHouse Cloud, where we actually use object storage to store the data and use compute and caching to generate those really fast queries, let us know. We're quite happy to help you on that front. Without further ado, so we have a program actually with a number of speakers. We start off, of course, with Sean from Cloudflare with a very interesting talk. Thanks for that in advance. Then actually we have an interesting company as well. It's in, I would say, startup scale-up phase, but we'll let ClipD do their own clipped or ClipD. I'm not even sure all the time. Clipped. And so that's an interesting. I mean, we got actually in touch quite early on because you're actually revolutionizing the golf world. So any golfers around here may be super interested in learning, but particularly from a data science and a data engineering perspective, that's an interesting talk. Then my own colleague, Christoph, who's based here out of London, by the way. He's the global solution architect. We only have one solution architect, that's Christoph. And he's going to do a talk around particularly trading data, tick data. So anyone with a quant interest or working for a bank or a hedge fund or crypto platform, I think in the last couple of months we've spoken to at least 100 different trading platforms that all have adopted ClickHouse for real-time P&L analytics, what-if analytics, bot optimization, etc. So anyone with an interest there. Then we have Daniel, there you are. Thanks for joining us as well with ClickHouse optimization for ARM. Super interested to learn what's happening on that front. I think we've spoken to a few companies already that have loaded ClickHouse on ARM, collecting sensor data, but I'm very curious to understand what you have to share. And then last but not least, my colleague Melvyn, he will actually provide an update on ClickHouse itself, and particularly about visualizing data. Melvyn is our support engineer, so if you ever try ClickHouse Cloud and you have a question, then Melvyn is usually behind the answer of those questions. So thanks in advance. Then, thank you very much again for joining us. Feel free to raise any questions. What I'll do, I'll try to stick to the timeline. We're already a bit over, but let's agree on 1 or 2 questions after each speaker. Let's move on. And we're here for pizzas, drinks, and all here till the rest of the evening actually to answer any questions that you may have. Yeah, thank you very much. Sean.
Thank you very much. Myself. I've drunk a lot of coffee today, so if I talk too fast, feel free to slow me down on the go. Okay, so today I wanted to talk to everyone about schema management. I'll define a little bit about what that is to me and what it is to Cloudflare. I'll talk a little bit more about how we run ClickHouse at Cloudflare. And then I'll talk a little bit about our sort of journey through sort of managing schemas at Cloudflare and what we do. So yeah, without further ado. I honestly searched for better pictures of my face, but I couldn't find one. This is the best you've got. I'm Sean, as you know. I work in the ClickHouse team here at Cloudflare. As I say, we love ClickHouse. It's a big enough function here that we have to dedicate a team to it. A team of 5 at the moment. And we do a lot of stuff. We own a lot of things around ClickHouse, tooling, automation. But as I'm sure anyone else that runs knows that anyone that runs ClickHouse at scale, we have to put an awful lot of effort into managing those things, upgrades, rolling things forward, and tooling to make those processes easier. Identity and access management stuff. So you've got thousands of users, so we've got a lot of tooling around that. So yeah, our team manages those things. And then what we actually use it for. So I think most of you will probably know, but our bread and butter is HTTP and DNS analytics. We've got goodness knows how many customers all over the world that we sit in front of, and they can log into their Cloudflare control panel and they'll get some fairly deep insights into how people are using their web-based applications. So that's a big thing. And then we've also got traffic and bot management. So our traffic engineering and network teams actually use it for fairly sort of deep insights into traffic management. So we've got data centers all over the world. We'll be able to use these. ClickHouse is a big source of data for that. So we'll be able to know whether we're seeing large attacks in particular regions, if regions are running very hot, in which case we need to route traffic elsewhere. So it's actually a part of how we route and manage our network. So low pressure Alexa. And other things such as workers analysis, Cloudflare workers, again, service direction. We've got a team, several engineering teams that manage that. They use ClickHouse at Cloudflare to get insights into performance, how the runtime performs, how they make it. And lots of other things. I could probably spend like 30 minutes and talk about how people are using ClickHouse here. I probably don't know all of them. So what we have, so ClickHouse at Cloudflare, we have 35 clusters, 2 of which are staged in the remainder of production.
that consists of step management 44 physical machines. We actually run those on bare metal nodes. The reason being is that we haven't actually designed an architecture yet that can meet our network or I/O requirements. As you can see from our storage, that's a compressed figure as well, 38 petabytes on disk. We process a tremendous amount of data. The write rate that we see and the network throughput we need to reliably replicate that to other replicas for resilience. We haven't been able to replicate that just yet, although it's something we're interested in working on. Something that's relevant to my talk today is the amount of schema changes. We have roughly 2 schema changes a day. Again, I'll clarify that a bit more about what that means. But this could be from an alter, someone adding a column to additional tables. But yeah, we see a lot of changes to schemas throughout the class's lifetime. The diagrams on the side are what hardware actually looks like at Cloudflare. So we've got 2 flavors, if you like. The one on the left is an NVMe-based node. 3.5 terabyte NVMe's, 250 RAM, and empty hardware. So we've publicly blogged about why we've chosen empty processors and why that tends to be the direction we're going. And sort of more of an older generation hardware being the old spindle-based replicas. I won't laugh at that, it's still we are facing that promise. So, what is schema management? Before I thought we'd talk about what we do at Cloudflare, I thought I'd sort of try and clarify what I mean by schema management, because it's a bit ambiguous. So I tried to define this as the process of explicitly defining both incremental changes and the absolute state of your schema. Incremental changes, schema migrations. People, I'm sure most of you will be familiar with this. That say if your first step, you have the create table definition, you have your table, but then you want to add a column. So you make a migration, which would be a file just changing that change. So adding that change, so adding that column for you. These are typically applied in order. And then you have absolute state. So actually what the table should look like, which would be inclusive of all of your migrations. And also tapped on the ability to apply and revert those definitions in the database. So yeah, an automated process. Why bother? Why am I talking about schema management? Now, why not just run create table T on cluster and then go to the pub? Why do we care? So it's important because if you don't have a definitive state of what your schema should look like, if you have anything such as a major incident or a critical issue, and you need to rebootstrap a cluster from scratch, it's not a trivial case to do so. It's not an easy process to do. So the idea being is you should have a state and know what your schema look like in production. So if you have a disaster, you can restore. Unmanageable with a large amount of data, a large amount of tables of views. As I said, we've got 1,100 of table of view definitions. I would not like to try and track those myself and make sure that was consistent everywhere. And the release velocity, as I said, is quite high as well. They're changing all the time. So it's a lot of things to track. Process to review. I think this is quite important as well, because if say me as someone that has access, as someone that manages the clusters, just runs the create statement or makes a schema modification for someone, and those teams that want to actually use these tables are responsible for it, they're not getting insight or feedback on that process and the schemas. So the idea being is that they can create a pull request that would add a migration or a definitive state of the table, and we can review it for them. So we can make sure that they're doing sensible things with replicated merge tree, check their parameters, check their index granularity, and do things such as capacity planning. So people often forget simple stuff like that. They create tables, start ingesting large volumes of data, next thing you know, clusters are running quite full. So it's a nice way to sort of engage with the teams and work with them. Access control, if we didn't have store these changes somewhere central in a version controlled system, we personally as a company don't allow everyone access to some clusters. So if we just had the definitions in production and we didn't have this version control system, have them in version control, people wouldn't be able to see what was in production. They wouldn't be able to see what they had. It would be very difficult, and that's important also for learning as well. People tend to look at schema changes and things that they've got in production anyway to see how other people have done things, learning off each other. So this is how we used to define them. We used to store these in a Git repository per cluster, which would have a bootstrap, which is the definitive state, if you like. That's exactly how the table should look if you need to start from scratch. And then migrations, so if someone wanted to add a column, they would add a migration, which would in turn adjust that starting table. We also have an up and down. So again, fairly self-explanatory. I think a lot of them will be familiar with it, but the idea being is that if you are applying a change, the up would have your create table and the down would be your drop table. And the idea being is that you always want to have a path to revert or go back, especially if you're doing an alter. If you, some of our clusters are sort of quite large. If you've got a 114 node cluster and you're running an alter across them all, and you come across a problem, you always want to have a path back, so you can put it back to its previous state. It actually hurts inside. So this is actually how we used to align, put the schemas in production. So it's a very manual process. The idea being is that I would SSH into, well, first I should clarify a few things here. So for those that don't know, we're quite a heavy user of SaltStack and Cloudflare. And that's a Python-based configuration management system. And we are, as a team, we are a tenant of Salt, if you like. That's how we configure our ClickHouse clusters and our replicas, exactly what we want to do. And it also turned out that was the tool that we effectively used to deploy the schemas. So the process that we do, like with Salt, you have a Salt master process, and what they refer to as a minion process, which will run on each replica. And the idea being is someone applying these changes after reviewing them and SSH into the Salt master. And then first, that's step one would be run a command that would effectively copy those migration files onto each replica in a cluster. When each replica has the migrations, you would then actually apply it. So the second command it's not doing anything particularly clever. It's just merely piping the SQL commands into the ClickHouse client on each replica. And then the response you get is just whether it's succeeded or failed. It's very much a Boolean response. I probably didn't need to include this, but I will. So manual time consuming, it was awful, absolutely awful. We all know that if you pipe SQL into the ClickHouse client, it's fairly quick. It shouldn't be a time-consuming process. But the problem is, we, as a team, ClickHouse, that is, we're not the only customer of Salt, if you like. I think we're one of, if not the largest users of SaltStack, to the point whereby the actual Salt infrastructure and the data structure that it has to render, and the amount of work that the Salt master and processes have to do, were incredibly expensive. So even for a trivial change, you alter table, add column. Even though that was quick, the actual Salt infrastructure to deploy that would take minutes, at times hours, especially if it was a big cluster. And error prone, I'd say. I don't know about you, but it was a manual process. And, we had to do this a couple of times a day. I live on my shell history quite a lot, actually. So quite often, rather than go to a process, being guilty here, I would pull up the previous command that I ran and change maybe the migration name to align with what was being deployed. but I may forget the other parameter, like the cluster name or something. So yeah, it was pretty painful. Static SQL statements. This is a bit more of a minor one, but because they were all defined as raw SQL, and we've got clusters that go back years, very early days of ClickHouse. And it means that as, say, syntax changes, so there's a new way to create tables, there's been other things that's changed. It means that as and when that syntax changes, you've then got to retrospectively go back and update all of those files. And it also, if you don't do that, as and when you add new replicas, if it uses your definitive state, it's going to come up and it could potentially be inconsistent. It can come up slightly differently, which could cause issues if the schema is not inconsistent. So what did we want to do about it? We decided that rather than have people write raw SQL directly, we wanted a higher level of abstraction that allowed them to just define what their tables look like. And rather than them having to write the up and down of bootstraps like I showed, they would just define their table in a higher level of abstraction such as YAML. We also wanted automated deployment rollback. We didn't want engineers having to go back and forth, SSH in and deploy these things. We wanted it to be an automated process. We also wanted state and metrics on these deployments, because if a human operator is monitoring these things from beginning to end, and an automated system is doing it, you obviously want metrics, and you want to know how that process is going. We also wanted to empower engineers to release their own schemas. So aside from the fact that it was very toilsome for a team, and a pain for a small number of people to do these things, we also wanted to give engineers and people that actually own these tables the ability to deploy their changes if they want, not involve us, basically. We can review the change and then they can merge and deploy as and when they want to. So this was our solution, and we call it Schema Manager, original name. But the idea here, so this is a Golang project that we started at Cloudflare. And it sits and monitors a Git repository and fetches new commits as and when they're merged. And it takes these high-level definitions. I'll show you what they look like in a second, but it will generate the SQL statements for you, both the forward, the rollback plan, and the bootstrap should you need to expand the cluster or bootstrap or replica. It's a stateful application, so as and when new versions emerge, so new commits emerge, it will synchronize with the Git repository you configured to monitor, and it will update Zookeeper. So current version here, being the current version that's on all replicas, the desirable version is the new shard of the commit that you've just merged into the Git repository has to watch. Failed. Fairly self-explanatory. I'll explain a little bit more about how we handle that and what we do. And state. I'll also elaborate on that a little bit. Yeah, effectively, once these SQL the SQL statements are generated, it runs them against each replica in the cluster is configured to use. So this is how things look. This is how you would define a table. Again, fairly high level, and it's all you need to define. I effectively write out the create table, the create database statements, and the create table statements for you. All idempotent as well. State as well. So I mentioned these a little bit earlier. So Schema Manager exports Prometheus metrics. So both. It has cluster states, which is effectively an aggregate of node states. And it's a finite state machine. So it has empty, ready, and critical. Empty is, okay, I've just been configured to watch these clusters and there's nothing that you bother in. I've got no commit information, there's no deployments happened. Ready is, I've done everything you've told me to do. I'm up to date with the branch that you've configured me to watch. Critical is if we try to apply a migration, so say we try to run an alter, the first thing the Schema Manager is going to try to do is try and roll that back. So it will try and roll back. So i.e. so if you try and run a create, it will run a drop. If the rollback fails, it will be placed in a critical state. And the reason why, well, critical state effectively means I'm not going to do anything until the human operator intervenes. If you merge new commits, it won't do anything. It requires state to be cleared from Zookeeper via a CLI. And we do that because usually if both a forward and a rollback fail, there's usually something going on that's sort of a bit fishy. We run integration tests against those schemas, so it's likely something to do with the cluster we're trying to execute it against. So the idea being it's a safety measure, and that we shouldn't be trying to do anything, we should be looking at what's going on. The transitional states, so this allows us to monitor progress. So again, we've got multiple provider dashboards that use the Prometheus metrics that we export and initialization. So again, this is if we're going from empty to ready. So say if you've added a replica, the idea being is that it would enter the initialization state where it would run all of those SQL statements for you. And then the end goal you want is the ready state. And rolling forward and rolling backward are fairly self-explanatory. So what's next? So table retention and TTLs. We have these already. So they're already existing. They exist already, but they're in SolStack. So the engineering teams that have to define them hate us. They don't like the fact they still have to make PRs for this system. So the idea being is we like to add functionality so that you can define your table retention policies. I don't want to keep any more than 7 days worth of data in this table. So they could, and we think the natural place for that to live is next to the table definition. UI component, again, the long-term goal for this is for it to be sort of allow people to be self-sufficient. If they're responsible for a set of table definitions, we'll add additional tooling on top of sort of the lower level programs such as the Schema Manager itself, so that people can do these things themselves. And then source version. So it's been quite a long journey learning about what we've needed out of sort of a schema management tool. So we've finally got to a place where we like to think about sharing it at least. There's a lot of stuff that's specific to sort of table patterns, if you like, such as adaptive sampling and whatnot. But generally, there's a lot of things that we could quite easily remove and make an open source version if the interest is there. So it would be great to catch up with a few people tonight to see how they've solved such problems and how they found it. Yeah, if they're interested. Other than that, that's me. So thanks very much for listening to the one for long. Please do let me know if you have any questions.
Questions? One or two? And then maybe two more. Anyone?
Am I loud now?
Yeah, go for it.
Yeah. Oh, okay. All right. The question was.
Okay. Hello. Thank you a lot for the presentation. It was great. I have a question of what happens if one of the replicas fail to apply schema change?
That's a great question. That's a very good question. So in that case, what you'd have is the states that I mentioned when you've got critical. In that particular scenario, what you'd have is the one node would fail, and you get a different alert to say that it's failed. The cluster itself would be failed, but you get another. The schema manager itself would log to say that it's failed to apply on that single replica, and that one replica will be placed in the critical state. And we've got two decisions then. Usually, the thing that leads that to happen is hardware failure, like I say, because we've got so many nodes. we would end up binning that node. So we'd pull it out, and then we use the system.clusters table as a source of truth for what replicas we would apply these migrations to. So the idea being is we would pull the bad replica out, and then the schema manager will be aware and see that that node's gone, and the overall state would be healthy again. But that's also one of the reasons why we don't use the distributed DDL, because we found it easier to not allow the whole migration to fail. So we just run against each replica. And if we have one that's problematic, we can investigate that individual things rather than have the whole thing fail.
Yeah, thanks for the presentation. Slightly recursive question. Do you happen to store any of this infrastructure's information in ClickHouse? And if so, how do you manage the migrations of that schema? Right?
That's another interesting question. Yeah, the short way out is no, we unfortunately don't use that yet, but it's an interesting idea, and we could theoretically do so. The only state that it stores is effectively in Zookeeper at the moment for the information we use. And the reason behind that is because we've got experience running Zookeeper production for that sort of storage. That's it.
Thanks a lot. Warm applause. That was a really good presentation. Without further ado, let's move.
Okay. Hello, everyone. My name is Chris, and I head up the data science team at Collect. So we are a tech company who are building a platform for golfers. Our key mission, essentially, is to help golfers get better faster, and that's across the full sort of spectrum of abilities. You've got to the top end of the game, the tour professionals, the best in the world, all the way down to the club golfer, the casual golfer. So what I want to do today is, first of all, give you an introduction to Click, what we do, how we do things, then look a little bit more at the technical side of things, what our data architecture looks like, why we chose ClickHouse, and then a couple of examples of exactly how we're using ClickHouse within the platform. So to start off, I'm not sure if there's many golfers in here, but some of you may be aware that over the last few years, golf has seen a massive boom. And that is in part due to the fact that we've had several new technologies emerge. And some of the more obvious ones are things like off-course golf experiences, things like Top Golf, Top Tracer. There's a number of indoor simulators that are popping up around London. But on the other side of things, more within the remit of the avid golfer, you've got a lot of technologies that are helping improve the on-course experience. So that's typically to do with sort of tracking shots on the course, and that is usually some sort of GPS device. So if I have an Apple Watch or a Garmin, it will be able to measure whether I've hit a shot. It'll put a GPS pin down. I'll go and fire my ball. I'll hit my next shot. Put another GPS pin down, and I'll be able to say, okay, well, that's a repeater for a shot. And I'll do that sort of sequentially throughout the round. And in doing so, you can then look back at the round and work out where you're been and how you can assess your performance. So there's obviously this huge amount of new technologies, and that means this new generation of golfers that are being brought to the game typically expect a connected experience when they engage with that. So we're basically at the point in golf where cycling was about 10 years ago before the emergence of Strava, and that completely changed, revolutionized the face of the sport. There's no cyclist today who doesn't understand the usefulness of data and want to record every possible sort of performance that they put in order to better themselves. The problem with that in golf at the moment is there's just so many options that you have as an individual, and that decision of which sort of technologies to invest in is made even more difficult by the fact that if I was to invest in one particular technology, my data is completely isolated in the software that's associated with that technology. So if I have a GPS device, I can go and look at the data that I have in there, get the insights from that, but I can't then associate that with any other activity that I have. Obviously, billions has been invested in all of these technologies. There's some brilliant solutions out there, but building up that sort of complete picture of the golfer isn't possible at the moment, and that's really where we come in. We sit in the middle of all those technologies and provide a unified software to allow people to fully understand their game. So what I want to do is basically step through what we do in 4 key steps, to give you an idea of how we go about things. And the first step, obviously, is aggregate. So this is really kind of the Strava portion of what we do. And essentially just bring all of your golf activity into one place. And that alone is hugely beneficial for a lot of people. So for the individual, the player, but sort of more importantly, the coach. Being able to see all of their players' data in one place is a huge time saver. You can see that on the post that we have down here with one of the coaches that we're working with, Kevin Sprecher. Being able to have a single login where they can see all of that data from all of their players in all of the different geographies that they coach in is a huge time saver. The second step is sort of what I've been involved in most, obviously working within data science, and that's the analyze step. And really what we're about here is understanding a player's unique golfing data. And we do that by developing an understanding of exactly what drives performance for the individual. And the way that I like to think about that is essentially building a new layer of intelligence which sits on top of all that aggregated data. And essentially providing insights and value that are more than the sum of those parts. Right? So as an example, if I have a device that can record data on the course, I have a top tracer range down the road from me, so I can go record my data in my practice. What we can do is we can bring that all into one place and start to connect the dots. I can start to understand how I play on the course and how that connects to how I practice. And that becomes an incredibly powerful feedback. And before I go on to the third step, I just want to dive into this in a little bit more detail, because obviously this is kind of the focus for the data science. One of the key focuses that we had when thinking about models and new metrics that we could develop was really to simplify that whole process. We've obviously got data coming in from a number of different places, a number of sources, lots of different formats. A lot of our users obviously don't have analytics backgrounds. So we want to be able to simplify that whole analysis process to make it very easy for them to understand their own performance and how to get better. And that process, we came out with these 2 proprietary metrics, which we call shot quality and player quality. Now, shot quality is essentially an objective measure of the quality of an individual shot, and that can be measured in any context. So that can be on the course, it can be in practice, it can be, as I said before, on the top tracer range, wherever it happens to be. I can measure the standard of that shot as long as I can measure the shot itself and its outcome. So here we use a simple scale from 0 to 200. 100 represents the standard that we would expect from a tour professional, so the best in the world. 200 represents perfect, so something like a hole in one. And then 0 is obviously the opposite end of that spectrum, essentially the worst shot that you could hit in a given situation. And that provides us the foundation upon which to build our other metric, which is player quality. And that's really about summing up the player's skill or ability in all the different areas of the game in a single number. So it has the same scale as shot quality between 0 and 200. Again, that 100 representing the standard we expect from a tour professional, and 200 and 0 on those opposite ends of the spectrum. And what that means is if we can subdivide a player's game into lots of different areas and assign a score to that, essentially they can get a full understanding of their ability at any point in time using a small set of numbers between 0 to 100. Very simple whole numbers to understand and digest. And so that brings me to the third point. It's all well and good having all of this analysis, all of these new metrics, but what does that actually mean for the golfer? And this is really where we drive the most value. It's about generating actionable insights for the individual. Okay, so here we're really talking about providing a personalized roadmap to improvement by understanding things like what's going well for a player, what's not going so well, where is there opportunity to improve, have we seen you better at a particular area of the game in the past, and essentially providing a prioritization of different areas of the game, what things require the most focus, essentially. And this leads very conveniently into the idea of gamified practice, right? So we've built our own companion app, which allows players to essentially select from a catalog of different drills and tests, which can assess their performance in lots of different areas of the game, very easily port that into the platform and get an understanding of how they're playing between, for example, their tournament rounds, or their sort of more formal practice sessions or anything like that. And the final point is the social element of the platform. So really are the place to compare and to share your golf game. We can put in any activity that you engage in your golfing life. That could be a practice round, tournament round, practice session, even exercise that's particularly relevant to your golfing performance. That all comes into the platform, and you're able to share that, compare that with your friends, or even to the best players in the world. Really, what we're doing is providing a new home for golf, right? Essentially, the golfing equivalent of if it's not on Strava, it didn't happen. So hopefully that gave you an idea of the depth of whole. Now I want to dive into a little bit more of the technical detail. So starting off with the data architecture. So on the right, we have a simplified diagram of our data architecture. You can see the ClickHouse. Obviously, fills quite a central role within that. But I want to start just with the ingestion part of the diagram. So as I've mentioned, we ingest data from a number of different sources. You've got on-course shots, as I mentioned, from things like GPS devices, and a bunch of information about the courses that people are going to be playing. Maybe it's practice sessions that you've recorded on a launch monitor device. We've got data license agreements with the two major tours in the world, so the DP World Tour and the PGA Tour. And then there's a whole bunch of other contextual information. So obviously something that's quite important for golf when you're playing outdoors is the weather. So bringing in that information as well to all the calculations. So this data comes in a number of different ways, either pushed through an automated API or via web scrapes. It's all stored in our raw data storage in S3. And that data is extracted and passed through various different transformation steps, essentially with the end goal of essentially building a normalized shots table, which we then store in ClickHouse. So the way that you think about this is an enormous flat table where you have each row representing a shot. You have the information about that shot, and then you have all the context associated with that shot. Okay, so that's all stored in ClickHouse, and then that feeds all of our different machine learning pipelines. And those are primarily built within Ray, which allows us to build distributed Python applications. So that sort of goes across the full spectrum. We've got some pipelines that just sort of output relatively basic sort of golfing statistics, things like the number of fairways you've hit, your accuracy, that sort of thing, all the way through to the more complex models that we've built in order to generate our proprietary metrics. And all of those come out and then stored in various analytics tables within ClickHouse. And then those feed the web app, through the GQL server. Okay, so why did we choose ClickHouse for our data architecture? Well, I thought it'd be useful just to sort of summarize exactly what we're doing, kind of in a nutshell. So obviously aggregating large volumes of user data across multiple different technologies, and then presenting those insights in a large number of uniquely designed but disparate individuals. Disparate visuals. And so some of the key benefits that are associated with that particular use case, obviously, the primary one was the cost effectiveness, horizontal scalability. We're obviously at the beginning of our journey now, but we're accepting more and more users. We want to be able to scale up our databases as we need to when we accept more users. A lot of the visuals that we use need or require table joins, so primarily with that core table, that core shots table. So we need to be able to easily manage those. And then the extended SQL support is really important for us as well. We have a lot of expertise within that in the team, so being able to sort of query the database, that is obviously sort of streamlines the process, makes that much easier. And the second point is the ability to store those nested data structures for shared visual is really useful for us as well. So I just wanted to finish off with a couple of use cases to show you where this sort of exists within the platform. The first of these is our player dashboard. So this essentially provides an easy to digest overview of a player's golf game. So this is basically the starting point that you would have in investigations of performance. So it may be that you're looking at this as the player, but also if you're a coach, maybe you're visiting multiple pages of all your different players. So it may be as far as some people go in their journey. So it needs to be able to provide enough information, but not be overwhelming, basically not show too much. And so this is really where our proprietary matrix sort of comes to the fore. They're able to convey a lot of information in quite simple numbers, and that's what primarily exists on this dashboard. And all of the metrics that you see here are populated directly by ClickHouse. So I'm just going to play this video here. So this is Rory McIlroy's dashboard. I thought that'd be a better idea than showing you slightly more depressing. So what I want to show here is that plot on the top right, that trend plot that you see. That is populated directly from that query that we have on the left there. And essentially what that is, there's 5 versions of this plot, which we'll cycle through in the video in a moment's time. But that shows you where the player exists at the moment on the furthest data point to the right. And then the trend essentially shows how that's evolved over time for that particular player. And the coloring is based on whether they're better than they were sort of a year, now versus a year in the past. So if it's green, that means they've got better. If it's red, they've got worse. Very simple, but it just gives that sort of initial visual view. People can really understand where they stand at the moment. And essentially what this query is doing is just selecting from our calculated scores table the most recent value in any given month for those 5 metrics that we have. So I'll cycle through these in the video here. And as I said, all the metrics here populated directly from ClickHouse, and you can see each of those segments here. So the second use case I wanted to look at was our player heat map. So here you can see by this query, it's a very similar format, but rather than selecting for an individual, we're looking at across a set of players. So this is really a view that a coach would use to get a high-level overview of the performance of their team. So it's found within our team, our coach's team dashboard, and essentially what it provides, as I said, is a high-level overview of how their team's performing and how their performance is trending over time. So again, I've got a video here that I'll start here. So this initial view, as I said, players are displayed in cards. You can see their absolute performance. Just a second. I'll go to the heat map view, where you can see in any given cell, you have the performance of that individual. And then the coloring is dependent on whether they've improved or got worse in that particular area of their game across time. So again, all of these populated directly from ClickHouse. You see the coach can very easily cycle through these. This is a team of about 20 players. And at any point, they can dive into that type's dashboard if they want a little bit more detail on them. That's it.
Thanks, super. Go first with 30 questions.
Yeah, may I have some question? Like when you're talking about cost, right? May I know like what is the minimum spec that required for the machine when you start the project? Sorry, can you repeat that?
Maybe into the mic.
Sorry. Sorry, I don't know English. So when you're talking about cost, like on everything that you're talking, I would like to know that when you start the project, what is the minimum requirement for your machine to run the GitHub for your project?
To run the algorithm.
Yeah, for the one that when you start your project.
So I mean, there's really no minimum. really, when it comes to running through the algorithm. Things like that. It's sort of built with the idea that some people obviously, that are obviously, at the beginning of their sort of data collection journey. So all of the algorithms that we build are really robust to sort of small numbers of data. You've got any individual rounds, typically sort of 70, 80, 90 shots.
So are you using the ClickHouse for primary database or just analytic database?
So probably, our analytics database, so to feed the front end on the visuals that we see within the platform.
Because you mentioned that you collect the raw data in S3 or so, right?
Oh, so that's the raw, as it comes in from the source, we store it sort of that single source of truth of the raw data. And then that sort of feeds through all the different
Meaning that you, for the machine learning, you use for the data from raw data or?
No, from the ClickHouse database. Exactly.
Thank you.
Okay, with the timelines in mind, and for the questions, of course, Chris, at the end of the evening or whatever, it's here. Next presentation is my colleague Christoph, like I said, a presentation on financial data and how to optimize queries and lots of current users.
Thanks. There we go. So I was asked to keep within 10 minutes and I have 35 slides. So let's see how it goes. But they're fun, they're low signals. So RAG data. So as we mentioned at the very beginning, one of the very popular use cases for ClickHouse is in the financial space. ClickHouse powers basically the trading platforms of several large US banks and European banks, a bunch of quant funds, market makers, a bunch of these people that make the financial system work use ClickHouse, because if you're doing trading, you need fast access to a lot of data. So that really is kind of a good sweet spot for ClickHouse. So kind of when you look at these kind of like real-time data feeds that you oftentimes get into ClickHouse, feeds for market security, then have things like the open. So at the start of the day, the US stock market, like all the stock markets open, everything opens, and you get all these opening auctions and opening prices. And then you basically get prices throughout the day, you get some volume information. Like that's kind of the typical sort of feed that you can buy this from an exchange or like from a market maker, from somebody. This is like what you then make sort of trading decisions on. Or maybe you're like Yahoo Finance and you power some kind of dashboards and you're doing something, you're doing top movers and calculations like that. There's also like this kind of data, like it's very similar to other kind of data. Like for example, if you're getting sensor data, you might have some kind of machinery or something that has a bunch of sensors in it. And some sensors provide data quite a lot. So like for example, temperature sensors, so like then maybe you have something like pressure sensors that don't provide the data that often, and maybe you have like a flow rate or something. So maybe this is some kind of like gas pipeline or some kind of electricity grid thing or something like that. Basically, the point being that when you have this kind of data, some things you get quite often, right? For example, if you look at financial data, right, you constantly get like prices. But for example, the open you get at the beginning, and then not again because it doesn't change during the day, right? Or the volume information you also don't get like with every single, you don't necessarily always get it, depending on the security. And so that leads to quite some interesting decisions about like schemas and current, and we'll get to that. And that's basically what the talk is about. So let's focus on that. So if you are getting in this kind of like time series data, especially like kind of tick data, you might start with kind of a table like this. The table will actually be more complex. There's more information than just these few, but sort of like some of the basics are we're getting a timestamp, we're getting a symbol. So this could be like a stop ticker, right? Like AAPL. Actually, I should say net for Cloudflare. But it also could be like a QSIP, which is like sort of a standardized IT for like all kinds of securities. You'll have a column for like the open, a column for the volume, a column for the price, and you might like order by symbol or timestamp, something like that might sort of make sense. It's not the greatest structure. One problem is that if you use Float 64 basically, then how do you distinguish between data points that, for example, have a volume or have it open and don't have it? Like it's a bit tricky. So one thing that you could think about is, all right, let's use nullable. And anyway, the symbol should be low cardinality because there's not that many symbols and it's going to repeat a lot. So like whenever you have a string that doesn't repeat that is not entirely unique, use low cardinality. It even works with like cardinalities of millions and quite well. And that changes the dictionary coding in ClickHouse. So kind of one purpose of this talk as well is to sort of spur some ideas for your ClickHouse installations, right? Like, for example, tomorrow, go look at your schemas, look at all the string columns, think about should they be low cardinality. Many of them should be low cardinality, and it really matters. It vastly improves data storage and it improves query speed as well. And so I generated a data set. It's very hard to get this kind of data. Like the exchanges make a lot of, like basically a stock exchange makes money from providing the data. It's not even really money from like the trading. I mean, they get money from the trading as well, but like money from the data feeds, that's what the exchange makes. So it's very hard to actually get good data feeds. Like they won't just give it to you. You can't just put it on the internet. So I had to generate my own data feed, and I generated a data set that is 234 million rows. And if I had more time, I would ask somebody to, maybe somebody knows why it's 234, but and I just did it in the ClickHouse, kind of a good ingest rate, 2.33 million rows per second. And what you then up with is like 2.8 gigabyte of data in ClickHouse. So actually, this is actually per second data for US trading day, and it's only 3 gigabyte in ClickHouse, right? So one of the measures of ClickHouse, encoding, compression, it's really small. And it's the data for 10,000 stock tickers, which is a little bit more than the US actually has. The US has 25,000 stocks, but I generated it like this. And so it's 234 is a magic number because the US trading day is 23,400 seconds, exactly 6.5 hours. But there's further optimizations that you can do. So I sort of started with this data set, and I started like putting it in this table, and then I ran some queries and I tried to optimize it further. So one of the things that really helps is if you look at this kind of data, right? You look at basically any data set with the timestamp column, which is one of data sets that usually go to ClickHouse, and you look at something like prices and volumes. And the thing actually is that, for example, the timestamp, one timestamp to the next timestamp in a row, it's not that different, right? It's usually going to be exactly the same or maybe slightly different. So storing the full timestamp is just a waste of time. Right? Most of the bytes are exactly the same as the bytes in the previous timestamp. So delta encoding saves that, and then ClickHouse only saves the difference between one value to the next value. And same for something like price, right? Yeah, I mean, of course, the stock market is volatile, but at the end of the day, like every stock trades at some kind of boundary. It's not going to suddenly go to 0 and then go to 10,000 or they'll be crazy. So also delta encoding really useful here. And the effect of adding the codecs is that in this data set, the data volume on disk goes from 2.87 gigabyte to 1.7 gigabyte, right? So like it's a huge save, right? So again, right, for all that here, right? Tomorrow, go look at the schemas. Look at the numeric values, look at like where you have floats, ints, all that stuff, right? And think about, do I really need to store all of the bytes for their value? Or should I use especially delta encoding? We also have like double delta encoding and gorilla encoding, there's other codings, but like so delta is the most obvious one that quite often really helps. And by the way, it's not just about reducing basically the cost of disks. I mean, that matters. You saw how many disks Cloudflare has in these machines, like 35 NVMe SSDs are not that cheap. But it's also about query performance, right? One of the biggest impacts that determines query performance in ClickHouse on any database, but especially like an analytics database like ClickHouse, is how much data do we have to read from disk to answer this query? And the lower the number of bytes is, the better. And so this is a cheap way to reduce the number of bytes. You lose no information, right? It's the exact same information, but you've stored it in a more intelligent way. And then you basically run this kind of query on top of this data, right? So like select, the symbols of the stock ticker, and then because you get, the open only at the beginning of the day, and then sometimes you get the volume, and then you get the price all the time. You need to use these argmax functions, and basically what they do is for each of these columns, the argmax function will go through the data for a particular symbol and look for the row where we have values for this and the most recent timestamp. And so I ran this query, and it finished in about 1 second. And 1 second makes me very happy. I mean, 1 second might be fine, but like if you're powering, for example, some kind of real-time dashboard, 1 second is a catastrophe. And anyway, you should always expect a lot of ClickHouse. So any time in ClickHouse is immediately suspicious. It can probably be faster. If you haven't done any optimization, it can almost definitely be faster. Number of bytes read per second is actually quite good. 10 gig per second is not too bad. But what I then did, okay, I went back and I eliminated nullable. Why did I eliminate nullable? Because the way that ClickHouse stores nullables, like nulls, is ClickHouse is a separate file where it stores the nulls as a mask to the additional file. So actually, when you switch your column to nullable, you go from one file, not quite right, but conceptually, you go from a file where you have the data to you have a file where you have the data and you have a file where you have the nulls. So, for a single query, it doesn't matter too much, but if you actually care about performance, it matters a lot because like now you have 2 files to read instead of 1 file to read. So instead, I switched to just a float 64, but then used -1 as a sentinel value because, well, open volume and price will never be negative, like these are all positive numbers. So, and then that makes the queries a little bit more complex, and you can see, but it's not too bad, and it actually provides an improvement. So with that, we need to switch to argmax if, so we need to always check. We only want the max if, like, this actually these are valid values, but only if the things are positive. And then actually my query time is improved to 0.7 seconds. Well, fine, that's an improvement. Gigabyte per second is improved a little bit as well. Still not that great, but fine. But it's really not great. So like it still doesn't really work for many use cases. Like if I am powering like from Yahoo Finance or from the Apple stock set, like that's still too slow. So what can I do? Well, what is the problem here? The problem here is really that these argmax statements, they get really expensive. And so if you have because what we need to do is we might have to go through a lot of data before we find the open, right? The open is only at the beginning of the day. So if we're towards the end of the trading day, we have to go all the way back to find the open, right? And similarly, who knows when the last volume information was? And like I said, this is sort of a very simplified version of what actually goes on. Like there's lots of other information that you get. And so actually, instead of having like 3 argmax queries, in an actual use case, you have like 10, you have like 20. And basically it scales like it increases this almost linearly. So like every argmax is like another like couple hundred milliseconds query time that you use there. So this needs to get faster. And by the way, another problem with having this kind of query take like 0.7 seconds, you might think, oh, 0.7 seconds, not too bad. But the problem is you don't just run the query and then you're done, right? You keep running it. And so like if you run a benchmark, you have this ClickHouse benchmark tool, you run 10 queries at once, like all of a sudden the 0.7 seconds turns into 5 seconds. Because you can only do 2 queries per second, right? So that's a problem. Now 10 seconds is even not that much if you have Yahoo Finance, or you're doing some kind of high frequency trading, you're not going to do 10. Let's do 100. Oh dear, all of a sudden we're 52 seconds, right? So the problem with slow queries is not even just that the queries themselves are slow, except that slow queries take up the resources of the server, the CPU, and the memory. And then this happens when we run a lot of the queries. And sort of just for fun, I also tried to run 1,000 queries, but ClickHouse didn't have enough threads. It's always fun to just like push it to the limits. And so what we can do here is we can use materialized views. Obviously, ClickHouse was sort of developed for, the idea is that you don't have to pre-aggregate your data, but of course also sort of like you do, right? Like if you have a lot of data, a lot without pre-aggregation in ClickHouse, more than other databases, but at the end of the day, at some point, of course it is faster if you pre-aggregate the data, right? So what I did here is just create a materialized view, aggregate on 5 minutes, and then basically aggregate merge tree aggregate functions. So we're going to store the aggregate states here, but otherwise it's basically the same as what we saw before. And then we have the materialized view query, where we just aggregate on the 5 minutes, and then we use these state functions to store the argmax states. Then we can later the full aggregation, so we actually bring it all together. And that gets us 790,000 records because there's 79 5-minute intervals in the first trading day, it's still 10,000 symbols, right? So the data is accurate. By the way, always check that your data is accurate. When I started doing this, like the first few times, it's like, oh dear, like the material SP does not have all of the data. And I could have just gone and ignored, and like if I hadn't checked it, right, like there would have been something wrong, and I would have thought like, oh, I solved the problem, it actually happened. Right? It's like always check, you know, with like materialized views, check that it actually works correctly, that you get what you deserve, that you can, what you intend, that you can actually explain these values, the count distinct, always check. And of course, the data volume is much lower, right? So like 1.7 gigabyte is the original full data, 7.5 megabyte is the materialized view, right? So much better to query. And then, of course, if I query the materialized view with argmax merge, just where I merge the states back together, 0.1 seconds, lunchback. And I did the same, of course, because benchmarks, 10 queries, 0.09 seconds, great. 100 queries, 0.9 seconds, still pretty good. It's 100 queries at once. 1,000 queries, it still works, 6.6. What do you think is going to happen with 10,000? I did test it, of course. Oh, well, that's a timeout. So, like, I probably could have, you know, just basically timed it out for 5 minutes, maybe if I increase it before 10 queries. But, you know, maybe if you have that amount of recurrent queries, maybe you shouldn't just have a single macro, you should just have a few instances that run dropping between or something. And then, so one of the remaining problems in this, it's very nice to query the materialized view, but what if I do need the actual data? Like, what if I do need to know during the trading day at any like single second, what is the current top 10 stocks, right, like that have got up the most? What are the current top 10 bottom stocks? Because, you know, I'm doing some kind of like algorithmic trading, and, you know, I'm basically writing some kind of momentum following bot that just looks at, you know, maybe I look at a point in time, let's look at the, you know, let's look at all of the stocks that are up by, you know, the most since the open, and then the most for the, and also up for the last hour, and also up for the last 5 minutes, and let's buy it somewhere, basically, right? By the way, do not do this. This is not investment advice. You will get eaten alive because there are people that write these bots that are very, very good. But you can think about, you know, that's could be like one component, right? Like you look at like what's currently going on in the market. And so you do need to have that information, but you don't have the time to query all the data. So what can you do is you can combine querying raw data and the materialized view. The reason why we built the materialized view like for like 5-minute intervals is that we never have to go past 5 minutes in the raw data. So like every 5 minutes we have a complete snapshot for every stock, what is going on, what's the open, what's the most recent volume, what's the most recent price, what's the most recent, and there's a few other things usually. And then we can combine the two, basically the query that you can use here. And I don't know if it's like the most optimal query, but it works quite well. With first off, we define what point in time are we do we care about? It could be now, it could be, it could be wherever, like it could be doing a lot of fancy stuff here. By the way, I've noticed that not that many people know about that we have a width in ClickHouse. So if you didn't know that there was width, there is width. You should use it. Don't just template the query and put it everywhere. Just do width as something and then use it in the query. And then what we do is we have just some outer slangs that's not so important, but then we combine querying the materialized view and the actual raw data. So this is the query for the materialized view. So there basically we're looking at, give me the data from the materialized view for basically the last snapshot before the point in time. And then combine that with just a simple union with a query on the raw data. But in the raw data, only look at the raw data from the last time that we created the materialized view, which is like to start of 5 minutes, and now, right? So we will never query all of the data. We will only query a maximum of 5 minutes of raw data, and the rest is the materialized view. And then I run this query. I thought I'd done such a good job, and it was terrible. It's like, how is this? I thought it was so smart. I reduced the amount of data that I'm querying. I mean, come on, like. And then, of course, what you do, and run explain, and you discover that, oh dear, I'm querying so much of the raw data. What is going on? And what is going on is that we were ordering by the symbol and the timestamp. And so basically, if you then do a group around the symbol, you're basically still querying most of the data because the data for a single symbol is stored together. So you need to go to every one of these basically chunks of data from the symbol. So what you do is you go back to the raw table, you sort only by timestamp, and then you notice, oh, sorting by only timestamp increases the insert speed. That's not what I was after, but it's interesting side effects. Also important, always try things, always experiment, you get results that you didn't even think about. So apparently sorting by both on insert, by both the symbol and the timestamp is actually like, I think it's only 2.3 million seconds, rows per second. But if you sort by only the timestamp, it's significantly faster, so quite good result. But also the queries are really faster, right? So like instead of like 2 seconds to 0.2 seconds, right? So doing this one change, I took away simply the first component of the sorting key. And I reduced my query time by 90%. Because I'm only querying 185 out of 20,000 variables, and before it was like 10,000, right? So like that's always what you want to look at. If you do any query optimization in ClickHouse, explain index is equal to 1 is your friend. That's what you need to do. That's what you need to look at. There's other things that you can look at, query log, trace log, all kinds of things, but this is the first thing, and this is almost always the thing to look at the leafing functions. And then you can do the benchmarks, 10 queries 1 second, 100 queries 24 seconds. So sort of kind of in the middle with 1,000 queries. So a few takeaways. One, ClickHouse is great for this kind of data. If you need to do aggregations, quick aggregations, and large number of data, that's what ClickHouse is for, right? So like market data, metrics, sensor data, like anything time series with a lot of data with aggregations on top of it. That's what ClickHouse is good for. Use materialized views, right? If you can. On their own, they're great, right? Super fast. But also you can combine materialized views with the raw data, very important. Often an overlooked use case. People think like, oh, if I use a materialized view, I will lose all the data granularity. But no, you don't, right? As long as you keep the raw data as well, you can combine the two. Sorting keys, very, very important, right? Always something to experiment, choose different columns, change the order of the column, especially the location of the timestamp column is quite important in the sorting key, right? Sort of the intuition is put it at the end, and that is oftentimes the right choice. But sometimes it's not, like in this case, like where we're actually doing like group wise on all of the stock segments. Having the timestamp at the beginning or only the timestamp is good. Avoid null if possible, because of how it's implemented. It's not for free. Measure everything, use ClickHouse benchmark, test concurrent queries, because that's what really that gets you. Like you want to query, you think like, oh, it's probably fine. Like, what if you want to query 10 times? Right? Which does happen, especially if you have like an externally exposed system, basically. Last thing, because of all this concurrency, like when the concurrency increases, eventually like ClickHouse errors out, right? Because like we run out of memory, we run out of threads, we run out of time. If you're building sort of a client, if you have especially an external facing application that is querying through ClickHouse, implement exponential backup so that you don't send 1,000 queries to ClickHouse settings. That's it.
Time. If you don't mind, in the interest of time, we move on. Christoph will be around. Any questions? If you want to start a career in cryptocurrency trading, he's the one actually to talk to. So that's another career change.
Don't use my trading as a shit. I'm not responsible for using data, for using money.
So the next speaker is Daniel. Daniel, thanks in advance for your presentation. That's what I want. That's the one. Yeah.
Yes.
Yeah, finally. So, hello everyone, my name is Daniel. I am from this company, which I don't represent today, so but I'm software engineer at Google. I'm ClickHouse infrastructure and efficiency contributor. I've already several years. C++ library was in the C++ standard committee, so I know all this magic behind C++, behind C++, yeah, not all, for sure, not behind ClickHouse as well. So, but first of all, I don't represent this thing, so no. I'm not from Google, but I am. But we recently released cloud machines, so I am one of the performance engineers for this project. So check it out. Like that's a multi-million business. Like we need that. Thank you. Yeah, this is a link, but generally what you should do is just Google Cloud Arm in Google, and you'll find the link. Yeah, now let's get started. So this is the most interesting part. I'm an efficiency and infrastructure contributor to ClickHouse. Yeah, efficiency. Why ARM? So first of all, why ARM? Like generally for the past 2 decades, I guess x86 was like dominating the server world, and like cloud was like picked up quite easily. Like when it started, was all x86, and up until 2018, I guess it was all x86 except some like exceptions from IBM or whatever. What happened? So generally right now, I believe I surely can say that our machines are 15 to 20% percent cost less than like, but the metric we're talking right here is per first dollar. Not like the latency or anything like that. So cloud finally provides cloud providers finally believed in all that. And I believe the real story is that a couple nerds from Amazon just tried it out and they figure out that it like works well, and really smart people from ARM managed to design a chip which can compete with x86, with Intel and AMD. It was kind of advanced. Then yeah, pretty much all cloud provider right now provides like ARM machines, so it's available almost everywhere. Yeah, I mean, money is put into this project. So from Apple, Google, Amazon, Microsoft, so corporations kind of pick this thing. And I believe the most important factor for this is just time. Like time has come that we finally need a competitor to Intel AMD, and ARM managed to do that. So thank you to them. So what are the technical reasons to choose ARM? So first of all, it's right now a little bit easier to develop in Evolve because ARM has like an open committee. You can like make a proposal, for example, like SV, like Scala vector extensions was proposed by the users and it was implemented by the users, apart from x86 architecture, which is like completely close to Intel. And like, yeah, memory tagging also was there. So we at Google managed to get like instructions for memory copy into the ARM versus V.8, V8.8, and right now has less legacy. Maybe it's done a little bit better than x86, but for sure I put a spoiler here. This will end at some point. Legacy like accumulates, and maybe in 10 years ARM will not be a very good chip provider. So yeah, for example, some obvious things like 4-byte instructions versus variable length instructions in Intel. So this is very good for decoder and like for like instruction decoder, and it becomes a bottleneck on x86. So yeah, generally ARM has more registers, so that means like less move registers and maybe a little bit better code gen. And it's a little bit simpler, easier architecture, which like has this good notion of keep it simple, stupid. And one more thing that I want to point out, that like software has gaps, and this is actually a pro for ARM because ARM already provides a good like performance per dollar ratio. Like in software has gaps, it means that it will actually also only increase unless, like I say, x86 competes quite well. And yeah, ClickHouse is awful. That code like is all the way ClickHouse. I'm one of the authors of this code. So I know that magic behind that quite well, and kind of like Intel was developing guides for a decade how to write such code, and I know it like some Russian people like do stuff like that. So yeah, I'm one of the authors for this guy. So, and why actually like ClickHouse uses the code? Because I mean, ClickHouse is a generally column-based system, and this is just an array of bytes. That's it. So array of bytes, CMD is great for that. So wherever we can find CMD optimization, we just do it. We don't stop. And yeah, for example, you can see ClickHouse is around 30% faster over the course of 4 years, and I believe around calculated, I believe around 7 or 8% is done by me. So I believe somewhere here, yeah, somewhere here. This one is like these queries are like about like order by limit and some string optimization, but I mean that doesn't matter too much. So first of all, like it's hard to learn CMD, and ClickHouse is packed with it. So and over a decade, as I said, like there were lots of guidelines. R did nothing according to like for the CMD stuff, which is called R Neon. And what we did, we fixed the glitch. We learned R Neon CMD by heart, and soon we'll publish some software optimization guides like from Google's attrition. And the situation is actually appalling. I promise you, it's nowhere near where like x86 stands. Okay, first of all, like there is generally x86 is very good on like vector scalar like transitions. So for example, you can read some vector, you can have, for example, you want to search for a space in it, and what you do is just you compare with a space mask, and then do so-called thing move mask. So you kind of have try to get so you have a compare. This is the result of compare. The byte is 0 if it doesn't compare. The byte is 0 XFF if it compares. Then you can call move mask, and it just provides you a 16-bit integer where 1 means like okay it matches, 0 means it doesn't match, and you get from the vector code to scalar code in one cycle. However, on ARM there is no such thing. It was a pain point how to do like string searchers, bind searchers, string comparisons, and so on. And ARM doesn't have anything like that at all. So, and some emulations on ARM which were provided as guidance by Apple were like saying that, hey, you can use just this translator, and this translator is like 12 cycles. That's not very good. And as I said, ARM, like ClickHouse is packed with x86 CMD. So what we decided to do is we found a very weird instruction called shift right and narrow. So how does it work? It produces 16-bit integers, shifts by 4, narrows, and this is a 64-bit integer where 4-bit groups are matching or not matching. This is almost a move mask, but like uses some weird instruction for ARM. And here is the table comparison for how you can use move mask and the results of move mask after that. For example, if you want to check that if nothing matches, then you should compare with 0. If everything matches, you compare with like 16-bit integer where 16 bits are ones, but like on ARM it will be like 64 bits. And pretty much very similar structures for both approaches. So what we decided to do, we decided to apply it everywhere. ZSD compression, 5%. 10% for byte search. Yeah, this is a C standard library. C standard library. ARM Neon is available like for 10 years, and we still find 10% improvements, and like still find me a simple 10% improvement. Hash tables, 7%. ClickHouse, PR for 500 lines of code, and 15% for string searches and string comparisons. 12% for what is that? Okay, this is like some filtering and grouping, I guess. Yes. 20% up to 2x for UTF-8 processing, and 20% for hashing and string comparison as well. So overall, 1.1% for all purists and 15% for string processing. And we also did some other stuff like fancy compiler flags, better branching, etc. The point I want to plant into your head right now that software gap still exists and the cost will go down. So do use ARM, and in the future, we're gonna do more, I'm gonna do more, because let's read more implementations, software guidelines, gap in software is right now is really, really big. Thank you. That's it.
Time. Shall we take one question, Daniel, and then maybe after the pizzas, etc., or after the at the end, more questions? Any immediate question? One question. Anyone? No. Well, more questions maybe after. Melvyn. So Melvyn is going to provide an update on ClickHouse with some more stuff. There you go. Thanks. That's
okay. Great. So I know that's what it feels like to listen to the last talk of the day. I'm going to try to keep it short and concise. So today I'm going to do a small introduction and then speak about ClickHouse updates. I'm just going to give you a preview of the next features that we're going to add in ClickHouse, because tomorrow is a release webinar, so feel free to join there. You'll be into much more detail what I'm going to give you. And then I'm going to show you how you can actually visualize that using Grafana and ClickHouse. So I don't know if anybody in the room has an observability use case. Yeah, a few people. So I think if you're using observability or even like business analytics or stuff like this, Grafana is a good option for that, and I'm going to show you how to use it very quickly. So that's me, Melvyn Peignon, the support services manager for ClickHouse. So every time you have questions, it's very likely that I see this question and I try to answer it. I'm based in France, I guess, as you can hear it, right? So it's a very weird accent, gave me away. Okay, great. So let's dive into the ClickHouse updates. So one of the new features that we're going to add in the next release, and I think it's probably one of the most important ones, is probably a new join algorithm for key value table. So for now, we have one key value table called embedded RocksDB. So it's basically a RocksDB database that is embedded within ClickHouse directly. So currently there is already like a join algorithm for it, but this new algorithm basically is much more efficient when it comes to memory. You will be able to use it as an alternative to the current algorithms that exist. It has better performance, and one of the main advantages it has like a constant memory usage when you're actually using the join. It will not work for all the join by default out of the box, right? For example, write and full joins are not supported out of the box, but for all the remaining joins, you will be able to use it. It's called the direct join. So we are going to, I don't know if you're using ClickHouse, and when you're using ClickHouse, if you're using the Play UI. The Play UI is just like a nice small UI that you can use to send query to ClickHouse. We are improving it, and one of these improvements is actually the ability to display charts directly within the Play UI. So basically, when you're going to use this new format that we released recently called JSON compact comment, if you're using it as an input, then you will be able to generate these charts at the bottom of the Play UI. A new feature that I like, especially because part of my job is to help customer migrating data from one ClickHouse cluster to the other. It's called the create table empty as select. So what is exactly this feature? So let's say, for example, you have a dev cluster and you have a production cluster. Maybe you want to take a table that you have in development and put it into your production, and you want to have the exact, the exact same table structure. So what you will be able to do is you will be able to create a new table in production, for example, and select the table that you have in development, and it's going to basically deduce the table structure from the select queries that you run, and it's going to create exactly the same table. Then you can use another query, for example, the insert from select. It's going to be able to insert the data that you're going to select from the table that you selected previously, and it's going to fill the new table with all the old data that you're, for example, in your development environment. We are going to have the SQL insert output format. So if you're using ClickHouse or any other basically SQL database, you will be able to use that feature to, for example, select data in ClickHouse and generate basically a file containing a bunch of insert statements. You will be able to define the size of the batch, the default tables that you want to insert the data into, and things like if you want to have the column names in the inserted values. So this is only a subset of the features that we are going to add to the next release, which is going to be tomorrow. There is a live webinar that needs to be done. You can register on the website. I think it's 5 p.m. This time tomorrow. So yeah, feel free to come there. It's Alexa and Christoph are going to be there. Yeah, so Alexa and Christoph are going to be there. I'm going to show all the new feature, and also there's a bunch of bug fixes, performance improvements that we're going to talk about. Great. Now, when it comes to visualizing data in ClickHouse, I like to do a demo, so I'm going to make a quick demo right after this slide. So basically what I'm going to do is currently I have data in S3 buckets, right? And I have also my ClickHouse cloud instance that is running right now. And what I'm going to do is I'm going to, from my ClickHouse cloud instance, retrieve these S3 files and insert them in ClickHouse. And I'm going to use Grafana to create like 1 or 2 visualizations very quickly. So what I'm going to do is I'm going to use an S3 table function. It's going to retrieve data from S3, and then from Grafana there is a ClickHouse plugin that I can directly use to connect to my ClickHouse cloud instance. So let me dive into demo mode. Hopefully everything works. Okay, so this is my ClickHouse instance right now. Just deleted some data. And it's actually running. So what I'm going to do is I'm going to go to Grafana. For people that don't know what Grafana is just like a visualization tool. You can have like many different data source. And the first thing I need to do is I need to go to the configuration and go to the plugin tab, and then I will need to search for ClickHouse. Right, I will be able to install it. Right, it's actually already installed, but it's just like click on one button and it's automatically installed. So not too much effort right here. So once you have installed your ClickHouse plugin, you will be able to create what we call data source. So it's basically the configuration that will be needed for Grafana to connect to ClickHouse. So the plugin is actually using the TCP address for ClickHouse, which I have in my notes. So I'm just going to fill this. So there is all my password and everything, but we're going to remove my instance right after the talk. So this is my TCP address for ClickHouse in the cloud. Now I need to have like the port, which is this one here. I need to make sure that we're using a secure connection. Then I will need to provide my username and password, which I make that still very secure, right? And that's basically it. All the other settings are basically optional. I can save and test. You can see it's going to test the connection to ClickHouse, and now I know that my Grafana can actually connect to ClickHouse. So once I have created my data source, what I can actually go is I can click here on data source. I can select the data source that I've just configured. Eventually, you can change the name here. You can call it London Meetup to make it more obvious. And what I can do is it comes with pre-created dashboard. So I can import this dashboard, right? And once this dashboard are imported, you can actually go to dashboard here, and you will be able to analyze data that you already have in ClickHouse. So this pretty friendly dashboard are just like basic monitoring dashboard, but it can give you idea about how to query ClickHouse or how to monitor ClickHouse. Basically, it's nice to have, like, if there's some metrics that you're interested in, out of the box it is already created. It's a very low effort for high outcome. So you can see, for example, that most of my rows are actually in the system table, etc., etc. Okay, so now I've configured my Grafana. What I need to do now is I need to go to my ClickHouse instance, and I'm going to start like filling it up with some data that we're going to then analyze in Grafana. So I have my instance running. The first thing I'm going to do is create a table that I want to use. So I don't know if anybody knows that data set is basically taxi data set. It contains like a bunch of information like where do we pick up customer, at what time, which place, in which neighborhood, etc. So I'm creating my table right now, and once my table is created, all I need to do is I need to use this S3 function. It's actually going to retrieve the data in my S3 buckets and package them into ClickHouse. So I'm just going to run this very quickly. And what I'm going to do now is I'm going to make sure that my data are indeed in ClickHouse. Let me check that very quickly. So I'm going to go to the mic. Okay, you can see I have around 1 million rows that has been added. So now that I know that my data are indeed in ClickHouse, I can actually start leveraging them in Grafana. So let me check if we can see that in the monitoring dashboard. Let me refresh my dashboard. And you can see that we have a new replicated branch tree here. So we have the table that we just created here. You can see default trips. This is the table I've just created. There's around 1 million rows. This is the count I just ran, so we know that my data are indeed here. So what I'm going to do now is I'm going to start creating a new visualization. So I'm going to go there, and I'm going to create a new dashboard, and I'm going to add a new panel right here. So when you create a visualization in Grafana, what you need to do is you need to select the data source that you want to use. Here I'm going to use the data source I just created, ClickHouse, right? And from this data source, then you will be able to use SQL editor. So I'm going to go there, and I can just copy paste any SQL queries that I want, and it's going to actually be displayed in a graph. So let me come up with one query, for instance, this one right here. So what is this query exactly doing? What is that right here? So basically, this query is selecting the neighborhood in which we have to pick up someone. And it's actually selecting accounts, and then we're going to group them by neighborhood, and what we want to know is how many people we have picked up from a specific neighborhood, basically, right? And I'm selecting the top 5 location, basically. So it's a simple query. But once you add it, you can actually put it into Grafana. So Grafana by default is actually going to say that a data is missing the time field, because like Grafana is used quite a lot for time series visualization. But here in this case, I don't want to visualize time series, so I can just say let's switch to table, and you can see that we're going to now have like the same data that ClickHouse gave me earlier. And the nice thing is that by default it's going to display a table, but you can actually change it to something else. In this case, I want to visualize, I don't know, maybe a pie chart. You can just select the pie chart, and then you can configure it. For example, I can say I want to display my the value that ClickHouse gave me, and maybe I want to have like a donut instead because I'm very hungry. And then I can select the field that I want to display. And you have like a bunch of different options in how you want to configure your visualization. Right, so this is like a very basic visualization. You can add a title, etc., etc. But it gives you an idea of how fast you can actually leverage the data that are in ClickHouse now. I don't know if you have like any specific favorites visualization, but one of my main visualizations, so the visualizations that I prefer, is geotype visualization, because I think once you have like, I don't know, like a region code, or if you have like a geopoint, it's always much nicer to display than the map. It always gives, I don't know, like the feeling that you put a lot of effort into this visualization, whereas you just put like a point on a map, and it's, I think the quantity of effort for the quantity of results that you get is very high for map visualization. So let's try to create one of them. So I'm going to discard this visualization, and I'm going to create a new dashboard and create a map. So basically, I'm going to again select my data source here, which is ClickHouse. And if we go back to my data sets in ClickHouse, I'm going to show you that basically there is two values in this row. That is the longitude and the latitude of where we actually picked up a customer. Right? So I can show you what it looked like. So I can run its query. I don't know if it's big enough. Let me zoom in a little bit. But basically, this query is saying that we're going to select the pickup longitude, the latitude, and the count. Right? So we're going to basically group them by latitude and longitude. And we're going to select, I think I did the top 100, something like this. So the top 100, yes, it's probably top 100. So you can see the highest value is always the default value that people actually put in their data set. So here it's 0.0, right? But then you start having like more interesting data points. Let's see what it looks like on the map, right? So I'm going to go back here. I'm going to go to the SQL editor, and I'm going to pass the query that I just ran. Right? I can actually run it, and I can actually select the visualizations that I want to use. So here I'm going to select map. You can see there is a bunch of different maps. There is heat map, there is geomap, there is world map. The geomap is the one that is actually of interest to me because it actually help you position a point on the map. So I'm going to use that. It's still in beta, but it works. Right, so as long as it works for me. And when you create your map, it's going to come with what we call a layer, right? I don't know if you're familiar with GeoMap, but basically a map is a collection of layers that you can put on top of each other. So for example, you're going to have like the first layer is always the map itself. So for example, here is the map of the world. And then on top of this layer, you're going to add, like for example, geopoints or like for example, areas or geo shape and stuff like this. So here you can configure your first layer here, and what I want to do is I want to say that I'm going to use coordinates, and I'm going to use the latitude field. So I'm going to select the pickup latitude field that I've selected in my query, and for the longitude I'm going to select the pickup longitude one here. You can start seeing that there is points being displayed on the map. Right, so it's the data set is called New York taxi data set. So you can see it's on your work. Yeah, it's in Africa, but I guess this is a 0.0, right? This is the default data set, and I can actually confirm this hypothesis by saying that the size of my point should be based on the count that I've selected here in my query. So now the bigger the point is, the more values there is. So you can see that it's the biggest one, and if you go back to the query that I've run earlier, it's actually the point that has the highest number of value in my table. Does that make sense? Okay, great. And now you have like your nice visualization that you can create in 5 to 10 minutes. And last slide, I promise. This time soon is going to be the time of pizza. But basically, how does it work? So you have graph and arrow here, and I've created 2 visualizations. If I put these 2 visualizations in the dashboard, and it's actually important to us that, is how it's going to work with ClickHouse. So if you know Grafana a little bit, Grafana is going to refresh your dashboard from time to time, for example, every minutes or every 30 seconds or every 5 seconds, based on how you configure it. For every single dashboard, for every single visualization, Grafana is going to set a query to ClickHouse to retrieve the information and refresh the dashboard. So each panel that you're going to create is going to send a single query to ClickHouse. It's going to be refreshed based on how you configure Grafana. Okay, great. That's the end. Thank you very much.
Okay, thank you, Melvyn. That was hopefully very insightful for anyone. I know pizzas are already being delivered. I don't want to stand in any way, actually, for those that are hungry or really want to dig in. We are around, Melvyn, Christoph, myself, Peter, you recognize us, and Melissa in the ClickHouse t-shirt. So any burning questions, or any of the speakers, by the way, that are still around. I want to thank everyone for coming over. Feel free to reach out if you have any technical questions, specific questions. I mean, we don't have we have a support engineer, but if you have a one-off question, you're stuck with setting up ClickHouse, you're running a POC, you don't know where to go, let us know. Reach out to me, or reach out today actually to one of the of my colleagues, and we'll definitely help you out. And yeah, looking forward to seeing you after the summer. We're back probably somewhere in September, October. We'll organize another meetup and actually see how we can get the momentum going actually around ClickHouse. So thanks for coming. Enjoy the pizza. See you soon.
Thanks. Yeah.